Hello and welcome to 6.5, Solving Square Roots and Other Radical Equations. You had a warm-up to do, and so I'm going to encourage you to go ahead and press pause and check your answers with these answers. And then I'm also going to tell you that it would also be a very good idea to just make sure, whichever path that you took, make sure that you still get to these exact same answers. So today, we are going to be using the powers property of equality, which says that if a equals b, then a to the n is also equal to b to the n. Please note, raising an equation to the same power may introduce extraneous solutions, so you must check all your answers. Remember, extraneous solutions are solutions that would make you have a statement that's untrue when you plug it into the original equation, like the square root of 25 equals -5. Not really, not true. For absolute values, it would be saying like the absolute value of a number equals a negative number. So anything that would make the original equation not true would be extraneous. Okay, so if you need to press pause now, if you need to check your answers or copy mine down, but we're going to go ahead and continue now. So the first portion here. Solve the equation, check for extraneous solutions. So if we're here, the first thing we want to do before we do anything with that radical is to get it by itself. So I'm going to go ahead and subtract 5 from both sides. And I have negative of the fourth root of x is equal to -5. I'm going to get rid of that negative sign by dividing by -1. And I have the fourth root of x is equal to 5. Now, opposite of the fourth root. So remember, when we were taking the square root, because it's like a square, we would square both sides. Now we're taking the fourth root, so I'm going to raise each side to the fourth power. Then these cancel out, and I have x is equal to 5 to the fourth. 5 to the fourth is equal to 625. Then you could do your check before you box it by plugging it back into the original equation. So 5 minus the fourth root of that is 5. That does equal 0, so this is now box worthy. There you have it. So number 2, remember, roots and then exponential radicals, kind of the same situation here. So I'm going to first divide both sides by 3 so I can get the variable by itself. So I have 4 over 3 equals 243 divided by 3 is 81. Now that fourth root, what we're going to do in order to get rid of that is we're going to multiply kind of by the reciprocal, only we're doing it on the exponent. So I'm going to raise each thing. So remember this rule, a to the b to the n. Oh, actually, I don't think those are the right variables, but either way, you would have a, and then you would multiply the exponents. So what would I have to multiply this by in order to get this fraction to go away? The reciprocal. So I'm going to raise this to the 3 over 4 and raise this to the 3 over 4. Cross canceling, the 3's cancel out and the 4's cancel out. And so I'm left with x is equal to, now the 81 raised to the 3/4 power. This is like saying the fourth root of 81 to the third power. Kind of a mess and not super duper helpful. So what I would like to do is look at that 81 and try to break that down a little bit. I know that it's 9 times 9, but 9 times 9 is like 3 times 3 times 3 times 3. 1, 2 times 3. Now the thing is though, this is 81 times 81 times 81 because of this 3. So 81, we know, is 3 to the 4th. So what we're saying is this is the fourth root of 3 to the 4th times 3 to the 4th times 3 to the 4th. There's 3 of them. 1, 2, 3, 1, 2, 3. Well, how many perfect 3's do I have? I have 1, 2, 3 of them. 3 to the third power. So x is equal to 27. Check it. 3 times 27 to the 4/3. Does that equal 243? I do happen to know that it absolutely does. Check. Nothing extraneous about that. It'd be extraneous if it was like taking the square root of a negative number or something like that. Okay. So for examples 3 and 4, we are told to solve and check for extraneous solutions. So as you've done before, I'm going to first go ahead and get rid of this, get the radical by itself. Don't square both sides until your radical is isolated. So go ahead and add 4 to both sides if you haven't done so already. And then you have the square root of 2x plus 8 is equal to 10. To get rid of this square root, I'm going to square both sides, and I have 2x plus 8 equals 100. Solve for x. Divide by 2, of course, and you have x is equal to 46. Not box worthy yet because I have not checked it. So square root of 46 times 2 is 92 plus 8 minus 4. Does that equal 6? Well, this is the square root of 100 minus 4. Square root of 100 is 10 minus 4 does equal 6, so that checks out. So that is now box worthy. All right, now this one looks a little bit different. It's because you have two different radicals. Them together is trouble, so we're going to separate them right now. So I'm going to add 3 radical 2x, add 3 radical 2x on both sides, and now I have the square root of 4x plus 28 is equal to 3 radical 2x. Are we done yet? Absolutely not. Now I want to square both sides to get rid of these radicals. So I'm squaring and I am squaring. On the left side, great, 4x plus 28. On the right side, here's the thing. Yes, this cancels out so that all I have is 2x. But when you square these, you have to square both of them. So 3 squared gives you 9. Don't leave that as 3 times 2x because that'll be a really bad situation. 4x plus 28 equals 18x. Now, you know how to solve this. I'm going to go ahead and press pause and let you solve it, and then you can check your work with mine in a moment. Okay, so when I solved, I ended up getting x is equal to 2, and then I did my check over here to the side. I don't know if you did or not. You can kind of trust mine for this one. Plugging it in. Remember, you're plugging it into the original equation always, always, always. So I simplified. I got square root of 36 minus 3 times square root of 4, and I got 6 minus 6, so this is indeed box worthy. It's not box worthy until you check it to verify to make sure that everything is all good. Again, don't forget, pause if you need to kind of check my work, see your work, and then if there's something you're not positive about, check in with me or a neighbor. Okay, next one. What are you going to do? Do the same thing that we did for the last one. I would love, love, love for you to start this on your own. If you feel pretty good about it, go ahead and press that wonderful pause button. If you feel a little bit shaky, roll with me. So first I'm going to separate them because them together, not a good look. And I get the square root of 2x plus 1 is equal to radical x. From here, as you did before, we square both sides and get 2x plus 1 equals x. I'll subtract 2x. And I have 1 is equal to negative x. So x is equal to negative 1 if you divide both sides by negative 1. All right, let's do our check before we box. Plugging into the original, I have the square root of 2 times negative 1 plus 1 minus the square root of negative 1 equals 0. This is a problem right here. Square root of negative 1, that's I. We're not dealing with i's right now because look, let's simplify a little bit more and make sure you see it. 2 times negative 1 is negative 2 plus 1, and I get a negative number here as well. Not okay. Not okay. Not okay. Why? Because the square root of a negative number is extraneous. We only want the real solutions here. This would be extraneous. Both of these. There's 2 warning lights on. So this right here, no, not boxing it, not box worthy. There is no solution, no real solution to this problem. I know, I was a little bit dramatic there, but still, point made. That's not allowed, not okay. So we're not going to roll with that. No real solution. All right, let's try number 6. And now, this is a little different right here. I'm going to give you a reminder first. Well, here's what we're looking at. Square, square. Left side, not a problem, love it. This side, not too much because there's 2 different terms there. Here's what I'm going to remind you of. A minus B is equal to a squared minus 2ab plus b squared. This is a special pattern. So this is like your A and this is your B. So when I multiply this out, I have 2 squared minus 2a, which is 2, b, which is radical x, plus b squared, plus radical x squared. Okay, x minus 5, simplified already, that's delightful. And then moving from left to right, I have 2 squared is 4, minus 4 radical x, plus x, plus x. I was thinking, these cancel out. Okay, let's try to collect our variables. So I'm going to subtract x and subtract x, and I'm a little bit happier. I have negative 5 equals 4 minus 4 radical x. This is looking better for me. I'm going to go ahead and try to isolate this radical so that I can square both sides. So I'm going to subtract 4, and I get negative 9 equals negative 4 radical x. And then I would divide by negative 4, as I'm sure you would. And I have 9 over 4 is equal to the square root of x. Are we done yet? No. We're going to square both sides. And I have 81 over 16 equals x, because these have now canceled out. Is it box worthy? I don't know. Let's check it and see. I, however, am out of space. I have kind of a hunch that you probably are as well. I also have a hunch that you're probably just going to watch me check this and not do it on your own, which is kind of whack. But plugging in that 81 over 16 into the original one equation, I have 81 over 16 minus 5 equals 2 minus the square root of 81 over 16. Well, this is fun. This is, if you do it in your calculator, which I'm going to allow for this time, this is equal to 0.25. And on the right side, if you do that in your calculator, you get negative 0.25. Yeah, I did it on the calculator. You're going to have to trust me. Is this a true statement? No. Not so much, not at all. So, what am I going to say? After all of this wonderful work that you all have just done, that we just did, mostly me, the answer to this is no solution. Bummer. But now we know. Doesn't happen. There you go. There are your notes for 6.5. Thank you so much for joining me, and have a great day.